I would like to warmly welcome you all to the second webinar of the Synergies project entitled Harmonization and Scenario Integration at SYCAM. Just to inform you, this meeting is being recorded. We are going to upload it later on at our YouTube channel and also disseminate it at our social media. My name is 𝗵𝗏𝗏. I'm Dissemination Manager of the Synergies project on behalf of ICCS, and I have the pleasure of moderating today's session. As you may know, or you will know today, Synergies is a European project focused on streamlining the testing and validation of connected, cooperative, and automated mobility, also known as SYCAM, systems through a shared European platform supported by a federated scenario data space and a tool marketplace. Today's webinar focuses on one of the project's fundamental goals, the creation of harmonized and high-quality driving scenarios, drawing from real-world and synthetic data, processed through advanced tools and integrated into a unified methodology that supports the broader SYCAM ecosystem. We are joined by 4 excellent speakers from across the consortium, and I'm going to introduce each of them before their talk. So let's begin. The first speaker, and we are very happy to have him today, as always from the beginning of the project, is Jordi Pont Rañé. Jordi is a project engineer at Applus IDIADA, 𝗵𝗿𝗏 and he's the coordinator of Synergies. He has a background in informatics engineering from the 𝗬𝗏𝗏𝗃𝗂𝗏𝗏𝗃 and extensive experience in both internal and European funded projects. His work spans across all phases, from development and testing to validation and delivery, always with a strong focus on collaboration and innovation. Jordi will give us a short overview of the Synergies project and its ambitions in the SYCAM space. Jordi, the floor is yours. Thank you.
Thank you very much, Dimitris. So let me share quickly my screen. So welcome everybody. As Dimitris said, I'm Jordi. I'm the project coordinator of Synergies. And for the ones that you don't know the project, I'm going to give you like a 5 minutes project introduction. So first of all, before talking about the Synergies, let's talk about the challenges and problems that Synergies is trying to answer. So most of these problems you already are aware of it. So you know that this number of possible driving scenarios that we may encounter while we are driving are virtually infinite. So what we also know is that autonomous driving must be reliable on every of these situations that we found. So if the number are infinite and driving autonomous vehicles needs to be reliable on every driving scenario, so here we have a problem and we need to address it. Okay, so we already know also that also the number of miles driving alone is not sufficient, so we need to combine this physical testing with the virtual testing in order to make sure that all these ADAS functions are safe. So having all these problems in mind, we end up in 2 main challenges that you see here below on the screen. The first one is how to make sure that enough scenarios have been tested and identified to make sure that the system is safe, and how to identify the right and representative scenarios for the specific ODD, so we know not to spend months and months testing and just to execute the specific scenarios. So from Synergy side, we are proposing a solution. The first one is that we are proposing a EU scenario database. So within Synergies, we are collecting data, processing this data, and generating scenarios, as you will see later in the presentation today. We will have this all of these scenarios put it on EU database, which will be accessible for everybody. But we do not forget about the already existing initiatives around Europe or even around the world. So in order to take advantage of these already existing scenario databases, we are continuing the development of this federated scenario approach, started on our previous project, SYNERGIES project, and continued the development here in order to interconnect all the existing databases from a single access point. Okay. And mainly, we are also creating a marketplace in order to help onboard new databases, to go through data quality procedures on the datasets, to work with the scenario databases. So there will be a list of tools, some of them free, some of them private, in order to facilitate the life on this world of scenarios. Okay, so very quick overview of the project. The project started past the June 2024, and it will last until May 2027. 20 million budget with near 30 partners, 29 partners. Okay, you see here that we have mainly overall representation of all the stakeholders and all the users of this platform. OEMs on board: BMW, Renault, Stellantis, Toyota, also tiers with Forvia, Siemens, 𝗏𝗏, and also service providers and research as usual as these kind of projects. The objectives and ambition, I would say that the main objective here is to deliver scenarios. Okay, also working on the right representatives and so on. But the main objective is to deliver scenarios, and we are not working only with scenarios being generated from our vehicles in the road, but we are also working and generating scenarios from different sources, up to 11, as you see here in the bottom of the screen. Accident databases, infrastructure, simulation, artificial intelligence. So we have plenty of ways to generate our scenarios. Okay. Finally, talking about key results and expected timeline. Usually on these kinds of projects, you need to wait until the end, so until May 2027, to see the project results. This will not be the case for SYNERGIES. So our intention is to release the first version of the platform in a couple of months. In fact, in a month from now, in order that we can start collecting feedback of this platform. Okay, so this is a platform made for the stakeholders, and we need to make sure that all their needs are covered. For this reason, we have during this first year of the project, we have compiled all the needs, talking with them. We will now release one version of the platform. We will put this platform under test on all of these stakeholders, collect again feedback, and then we will still have 2 more years and 2 more releases to improve this platform. So first release on November 2025, second release on May 2026, final release at the end of the project, June 2027. Apart from delivering this, the SYNERGIES platform, for sure, the main key results are these open datasets from different sources, these best practices for data collection and scenario extraction, this set of tools, and for sure the stakeholder engagement, because we are also talking with vehicle safety bodies, with international initiatives, because we do not want to make this work alone. So many other people have already started doing this job, and we want to talk with them and to be aligned with every entity and organization that is delving with this topic. Okay, so this was very, very fast SYNERGIES topic introduction. Now my colleagues, the technical experts, will explain you more about the whole process from data collection until scenario generation.
Thank you, Jordi. Before proceeding to our next speaker, I would like to tell you that if you need to make any questions, you can use the Q&A option that you can see on the top of your screen. Of course, you can raise your hand and I will grant you with access to open your camera and microphone, shall you wish it, or you can use, of course, the chat. So, next, we turn to Dr. Vasilis Bill Roungas, senior researcher and colleague at ICCS, project managers of the events of the SYNERGIES project. Bill holds a PhD on games and simulations from TU Delft and brings over a decade of experience in transportation and logistics, having worked in the Netherlands, Sweden, and Greece. He's also an assistant professor at the Department of Communication, Media, and Culture at Panteion University. In this presentation, Bill will talk and walk us through how Synergies collects, qualifies, and integrates a wide range of data from public databases, and partner contributions to real-world sensors and AI-generated data. Bill, please go ahead.
Thank you, Dimitris. I will share now my presentation. Can you see it?
Yes, we can see it. You can proceed.
Okay, perfect. So as Dimitris said, in this first presentation, I will go through how in Synergies we go through the data analysis, collection, and generation of datasets. So a quick overview of the presentation will show a very 1-2 slides project overview and how everything fits. Then we'll talk about the data qualification methodology, and then I'll go through how we have collected different datasets from existing sources, from external sources, through data collection and from vehicles, through data collection from simulations, and through synthetic data generations from AI. So as a project overview, the part that I will be talking in this presentation is within the Synergies project is part of work package 3. And this feeds to the next 2 work packages, mainly to work package 5, for which, as work package 3, we will provide the qualified datasets for the scenario creation, and also to work package 4, where we'll provide datasets which will enable the development of different tools. Now, on the data collection and the data qualification, as I said, there are 4 sources of data. The first source is data from external sources, so pre-existing datasets. Then within the project, we will generate data from vehicles and from other infrastructure like roadside sensors, drones, etc. Then the third source will be data generation from simulation tools. And finally, we'll also have synthetic data generation from generative AI methods. Then, after the collection of this data through a data qualification methodology, which I will show right after, we will, let's say, label those datasets that we consider to be qualified in an object level, as well as also have the raw datasets for different purposes. Now, I will start with the data qualification methodology, which will use it for the data quality assessment and assessment of the potential of quasi-stationary sensor units for high-quality scenario creation. Now, within the data qualification methodology, we follow a 2-step approach. The first step is using a high-level qualification methodology. This is some sort of let's call it a face validation, which enables to do a quick screening to identify datasets that meet some essential quality criteria like coverage, accessibility, documentation, the metadata, the licensing. And here we either put a pass or a fail score. So we either discard a dataset or we keep it, then in order to be able to move it to the second stage. And we consider this 2-step approach to be an efficient allocation of resources. So we assign the minimal possible resources in order to be able to filter datasets that do not meet the basic requirements that we seek. And then those datasets that pass this first, let's call it stage filter, we then take them through the process of a detailed qualification methodology, which is an in-depth assessment of dataset quality based on multiple dimensions like accuracy, completeness, consistency, timeliness, coverage, relevance. And here there is no pass or fail. Here we have quantitative metrics and specific thresholds. And this process ensures that datasets meet rigorous standards for usability in SYCAM scenario generation. Now, this is a decision tree. I will not go through all of it, but this is a decision tree of the high-level qualification methodology with the different, let's say, pillars and the different criteria within each of those pillars. And how we see it is that in order for a dataset to be able to qualify to go through the detailed qualification methodology, it needs to pass all those criteria. So you see below that a pass means that all criteria are answered with true and none of them is false. If any is false, then the dataset fails. So moving from the data qualification methodology to the first source of data, which is data available from external sources, so pre-existing data, which is either from open datasets, other related projects that were willing to share the data, or from partners within the project that were also willing to share. Here we initially identified 160 datasets, which came from the three sources that I just said, so public datasets, relevant projects, and partner-owned datasets, which consisted for driving datasets as well as accident datasets from both real data and synthetic data. And we created then a taxonomy for the driving datasets and the accident datasets. And then we passed it through the high-level qualification methodology, which then allowed us to qualify only 69 datasets. Then we performed the analysis in order to be able to find gaps. And by gaps, I mean underrepresented features within these datasets. And we also did a metadata analysis. And here is a, let's say, I would call it a high-level overview of the results that we found. So in terms of sources, most datasets have recorded from mainly the ego vehicles point of view, as we see, with very few drone and V2X datasets existing. Then with regards to the lighting sources and weather, of course, as expected, most datasets were recorded in clear weather and good visibility conditions, and with underrepresented datasets on adverse weather and low or very low visibility conditions. And most datasets have been recorded in an urban environment with very few rural and roundabout datasets. Then moving to the next source of datasets, which is the data generation from vehicles, infrastructure, sensors, drones. Here, each partner has built what we call a data collection journey. So they start by creating a campaign design, so how they expect to collect the data, and then that could be, for example, a vehicle, an infrastructure sensor, the drone, and then starts the raw sensor data collection, the recording, and then the next step is to be able to perform an object detection, classification, and tracking, and in parallel to provide the high-definition maps of the recording sites. And these, let's say, two inputs, the object detection along with its classification and tracking of the objects, and the maps feed and we convert these two into what we call the SYNERGIES data format. Here is, let's say, a high-level view of how a data journey, actually 3 different data journeys look like. So we start with different sensors, And then we collect the data, and then, as I showed exactly in the previous slide, we do the object detection, classification, and tracking along with the maps that we then be able to convert to the scenario source data, as we call it within Synergies, or generically speaking, we call it Synergies data format. So that was the second source of dataset of data collection. Moving to the third, which is the data generation from simulation, in which we aim to generate simulation data for potential critical scenario, edge or corner cases, and scenario variations based on given real-world scenario data. Here again, we have what we call a data collection journey. And similarly as with the real vehicle and the infrastructure, we have the different sources from different partners. So different, let's say, tools in this specific case. The predominant tools used is the Carla simulator and the GEMSTAR simulator. And less, but also heavily used is the SimSetter Priscan and the scenario engine. The process for any simulation tool is the same. And in this case is we get the data from the simulator, we convert it to the ground truth OSI trace, and then we also collect the sensor data from the simulation, which then we can convert to the Synergies data format from the two simulation, and the sensor data we convert into to the sensor data according to what we collected from the simulator. Here is let's say an overview of the two main simulators used within Synergies. On the left, it's Carla simulator, which provides an autonomous driving sensor suite, and it's very useful for fast simulation, for planning and control, for generating maps, for simulating traffic scenarios. It's also able to integrate ROS and provide also baselines for autonomous driving. On the right is GEMSTAR, which is based on the Unreal Engine, and it provides a native Sumo and S-Mini integration, and also autonomous driving sensor integration via the FMI. Here on the right, we show how the different sensors are part of the simulation model. So camera sensors, LiDAR, radar, that can offer both the object and also the geometry of the scene. So moving to the last dataset generation source, which is the synthetic data generation with generative AI, with which we aim to enrich existing data, real data and simulated data through some, let's call it, filters that produce to generative AI. And here, as I already said, we have input, as an input, we have the collected data, the simulated data, and all the data that we collected in our in the first stage, or public data sets, etc. And we feed them to different, let's call it, AI modules. So I will explain these three modules. The first one is a simulation to real transformation. This is performed by having trained a model, an AI model, having trained it with real data, and then applying this model to the simulation data in order to convert them into raw sensor data that are much more realistic than the ones produced initially from the simulation. Then the second module is the domain transformation. In this case, we have raw sensor data that we are able to clean and also provide artifacts on them. So put artifacts like rain, like snow, low visibility, fog, etc., that are quite realistic. Lastly, we have the large language model, and the idea is that we can take the raw camera data, and through a large language model, we can automatically convert them to the Synergies data format. And here is, let's say, a graphical depiction of how this works. On the left, it's the input, so different, let's say, images, and then we prompt and we say, for example, add some rain, and then this goes through the generative AI model, and then we have images produced with rain. And also we have a video generated from an image. It's just 2 seconds, but it's actually a video that it's produced from an image. And these were the 5 main sources of data collection. So as a summary, the recordings that we have been doing aim to fill the identified gaps that we found in the existing body of data. And so far, we have managed to add to the body of datasets these datasets that fill the gap with regards to adverse weather, with regards to the environment, so less urban and more rural, and also some more with regards to, for example, drones, so datasets recorded from drones. So that was my presentation for today. Thank you very much, and I guess there's no questions now. They are in the end, Dimitris. I'm not sure.
Even if they are, I see that we have already a question. We will address them. We will address every question at the end. Let us have first all the presentations. Thank you, Bill. Our next speaker is Dr. Marcos Nieto, head of the Connected Cooperative and Automated Systems Department at Vicomtech, our partner based in San Sebastian, Spain. Marcos earned his PhD in electrical engineering from the Universidad Politécnica de Madrid and has since led numerous research projects in the automotive sector with strong expertise in AI, data processing and semantic technologies. Marcos will explain how the project processes raw sensor data and transforms it into usable scenario source data. So Marcos, the stage is yours. Thank you.
Thank you very much, Dimitris. Yes, so my name is Marcos. I'm with Vicomtech, and I have the pleasure to be participating in Synergies and coordinating Work Package 4, which is related to the data processing aspects of the project. Let me move forward. As we have seen previously, we've seen the Work Package 3 activities. I will talk briefly about Work Package 4, which is about these heterogeneous AI data processing tools and data interoperability, which fits into the breakdown of activities in Synergies in this second place. And as a consequence, the scope of the Work Package is to leverage object detection, tracking, data fusion, and other tools, as we will see, as a way to process the recordings and the real world data that has been created into the metadata that is object level and scene level necessary for extracting the scenarios of interest. If we take a look at the challenge ahead of us, this diagram explains the question of data processing. The scope of Work Package 4 is to input different type of collected data, and that implies different type of sources, which include onboarded cameras and other sensors in vehicles, but also drone equipment, like cameras typically looking down into the traffics, but also static surveillance devices like cameras or LiDAR. But also the problem or the challenge is that many different data sources, as we've seen in the previous presentation, may have different data formats. They may have been produced by a vehicle equipped with ROS middleware, or some others would be open data sets already available in the scientific community, and that they may have other data formats, and not only data format, but also different metadata taxonomies. They may call differently objects and classes and relations between them in terms of spatio-temporal relationships. And as a consequence, we may understand that we may have like a number of different data providers, if you wish. The idea of these data processing tools of this 𝗬𝗏_𝗏 is to provide mechanisms to process all these different heterogeneous data sources, raw data sources, into a common and single scenario source data that will follow the already commented SYNERGIES data format. Okay, so it's about data processing, right? What do we mean in this context? We've already seen in the previous presentation one of these data journeys. They look like this. From left to right, the data is captured by sensors typically, and then they go through a set of steps towards their ultimate goal of being following the SYNERGIES scenario source data format, which contains object level information like trajectories, classes, and many other necessary metadata about the scene, plus also the static layers like such as the OpenDrive maps. The interesting thing for us here is that these pipelines of data processing are composed by atomic pieces of processing elements. You can already see things like 2D object detection, 3D object tracking, and so on and so forth. So eventually we will end up building a lot of these pieces, and each of them fulfilling a particular goal. Some of them, especially those at the edges, like at the left interface and out interface, will be converters. So we will be producing a lot of conversion mechanisms from one format to another, while in the middle we have actual, let's say, processing components that elaborate higher level information out of raw data in general. Let's take a look at type of components we are talking about. We are usually talking about point cloud accumulation and rectification. For instance, if you have a LiDAR sensor and then also an odometry mechanism, then you can compose a 3D map of the environment. We are also talking about image processing and anonymization. Symptomatic labeling, that implies that the user takes some action and then clicks and drags and performs all the type of actions onto the recording, so that there are some manual labor behind. But also we are talking about AI-based object detection and tracking, so the capability of the system to detect, classify, and assign a temporal coherent ID to objects in images. We will be also building tools for visualization and playback, because usually this is helpful for finding scenes of interest, and in general also semantic inference, which implies how to build up semantic information out of basic object level information, which doesn't have maybe the relationships between the objects and the actions behind. Let's take a look at some of them that we call the tools. For instance, we like to highlight one of those that are related to the compliance with GDPR, which is a topic of interest for many stakeholders. When recording video data, pedestrians and license plates might be exposed, and one of the tools are expected to be running real time. As we can see in the left, the idea is to obfuscate these sensitive information, the information that contains potentially privacy information about individuals, and extract information about these shapes, like the body parts and so on, so that in a second stage, at the rightmost of the slide, we can use generative AI to build synthetic or fake pedestrians. The idea behind these synthetic pedestrians is that the images are clearly non-realistic, so there is no private information of pedestrians, but realistic enough to be used for different purposes like training or testing algorithms. Of course, we have the usual works on 3D object detection. Let me see, sorry, if this plays, the video is not playing, 1 second. Yeah, let me click. Usually 3D object detection has the goal of locating objects within a 3D space, and as a consequence, if the GNSS RTK system is available, then these signals can be compensated in odometry, and as a consequence, the objects detected in the point clouds of the images can be located into their into the geo preference. But often we are talking about 2D image analysis, where finer things can be detected, like the presence of lane markings, free space, or other objects. Last but not least, in terms of tooling, it's important to understand the complexity of the recordings we are talking about. So it's not a single image, so not a single camera or a single point cloud. We often have vehicles equipped with multiple sensors. And as a consequence, we need complex tools like the one that we are also building, which is called web level, in which you can play not only the raw data, but also the already produced metadata, like the dynamic objects, the underlaying, maybe lane markings or curves or any other thing, plus the actions, events, and all the context that might be of interest for the purpose of extracting scenarios. In the video that it is playing, I hope you can see it with a good FPS. For instance, we can see a sequence in which the ego car is performing an overtaking maneuver on parked trucks, and there are some pedestrians, some workers working in this scene. So the ultimate goal of the labeling is not only labeling the presence and the type of the object, but also the maneuvers behind. Like, for instance, if this is an overtaking maneuver and there is some risk, for instance, of colliding, or potentially if there is any additional future development of the situation, like imagine the pedestrian starts walking into the other lane. So all of this is part of the job that is supported by the semantic framework, by the way, because the semantic framework is the one that can link objects with actions and with relations. My last slide is about the tool marketplace. Jordi already said a few words about that. As one of the goals of Synergies is to offer all these tools that we are building as atomic pieces of functionality into a tool marketplace that will be exposed in a website like the one I'm showing in the slide. They will be offered under different licensing options, and each tool has different nature, so there will be a different type of offering, but hopefully as the project evolves, this will be clarified as part of the impact section of the project, how to offer this, but the website is already under development, and some of the tools have already been released, and soon we'll be having I would say a catalog of tools to be offered. I think that's all from my side. Thank you very much. Happy to answer any potential question. Thanks. Dimitris,
Gracias, Marcos.
Yeah.
Yes, sorry, I was muted. Thank you very much. We will take all the questions at the end of the next presentation. So having said that, our final presentations comes from 𝗵𝗿𝗏 task 5.3, lead in synergies and expert in scenario-based assessment at the Institute for Automotive Engineering of Aachen University. 𝗵𝗿𝗏, Master of Science in Automotive Engineering from the University of Aachen, and an MBA from the Collège des Ingénieurs. Prior to joining his organization, he worked at Volkswagen Commercial Vehicles and now focuses on harmonized methodologies for scenario creation validation. Today, he will present the project scenario generation concept and the tools being developed to support a broad range of CCAM testing needs. Christoph, over to you.
Yeah, thank you very much for that kind introduction. Let me just also share my screen, which you should actually see right now. So as I said, I'll talk today about the scenario generation process. And as we already talked about work package 3 and work package 4 of Synergies, well, really surprisingly, I'll talk about work package 5, which actually makes a lot of sense because it's just the next step in our chain, which we have to consider. So basically, we've already seen that we collect data, we've seen that we process that data. We've talked about something which is called scenario source data. I'll come to that in a second, because that's then really the essential interface to work package 5. And after talking about that scenario source data, I also want to talk about the generation process itself. Why is it important? Well, we want to have a scenario data space also as part of the scenario database to some extent, and therefore, well, we do need that scenarios, which we basically extract from data, but not only from the data which we have, but actually we do have there also some other methods I'll come to in a second. So as said, 2 basic points. First, I would like to talk about the scenario source data, which is basically the interface. And that slide I'll show you, you've already seen from Marcos. So we do have the data collection, and we do have a lot of different data providers. And not only different data providers, but also different quality and sources where that data comes from. We've seen that we do have, therefore, also some different data processing tools and data journeys. However, at some point, we have to have a so-called merging point, meaning that we don't want to have specific tools for specific data journeys, but we really want to have that one single point of truth, because what we do is that we have a lot of different tools to identify, enrich, and generate scenarios. However, those should not only be specific to one data source, but really be generalized, and therefore we have created that scenario source data format. Well, one more thing here. I'll focus, whereas the other 2 presentations were more about the first part, I'll have a look at the right part. So what's actually the scenario source data? We've heard about that. It's basically 3 elements we do have in there. So we do have dynamic elements, which is basically everything which comes down to the trajectories, positions, velocities, dimension, vehicle types, or road user types. Then we do have the static information, which is, for example, the digital map. So everything in the 6-layer model, layer 1 to 3. And I think sometimes forgotten, but actually really important for our data space is metadata, meaning that we do have to have the information who actually provided the data, when it was recorded. May there actually be some bias in that data, which has to be accounted for in our scenario identification and generation process. So that's basically the 3 information we do use here. How does we actually do that? So therefore, we have built a format, and well, there are actually formats which can be used. However, having here a look what we actually need, or we actually talk to our stakeholders, and it was important for us that we does not create a completely new format, but really building on what's already out there. So we screened these formats which were available, and in the end have now created a format based on that, as you can see on the left side, based on ASAM. So it's basically an OSI trace which we have. We considering OpenDrive. We also considering comments from other projects, as for example HiDrive and VBM. And then we came up with our format 𝗲𝗏, which is not only a project internal format, but which we also published. So you can see the links here on the right side. On the one side, the specification, but also reference tooling that it can really be used quite easily. And I said, so we are using that in the project, especially as an interface to work page 5. But it can also be used outside because everything here is available. So with that having said, that we do now have input as trajectory data, map data, metadata. We then use that for our scenario generation methodology. And of course, there's not only that one method which is out there, which already exists. But what I'll talk now in a minute about is that in the end, there are different tools. Actually, none is really comprehensive. And we do need certain tools for certain specifications. However, it's not sufficient just having certain tools next to each other, but we have to speak a common language. And therefore, consistency and harmonization is a particularly important thing, which I'll talk about, because that's quite important then using different methodologies in a certain data space and using them, for example, for safety argumentation. To achieve that, so achieving that we do have a harmonized scenario generation methodology, we basically do have 4 building blocks. We do have a so-called scenario concept, which is basically a common language which we speak, how scenarios are described on certain abstraction levels. And then we do have 3 building blocks, which are then more on the tooling side, which are about collecting, exploiting, and also projecting. And there are always some different parts in there. So for the scenario concepts, we have a look at abstract scenarios, at logical scenarios, of course, and in that, then the concretization definitely as well, concrete scenarios. For the collection, we have a look at the scenario identification, extraction, actually also enrichment. And here stated as another point is the non-ordinary situation identification, which has to be treated a bit differently. With that, then, we use that information to exploit, meaning that we have several stochastic processes analyzing that data. And then from that analyzation on, we generate concrete scenarios, which can either be general scenarios or test scenarios. And then we do have the projection, meaning that we actually utilize these tools and also scenarios so that we can go into simulation and actually also bring the human in the loop here and assessing scenarios which we haven't investigated, but making deviations. Let me just quickly go through the individual points. So as said, we have to speak a common language, and therefore we do have our scenario concept, which is basically one framework which is considered by all the tools developed. And therefore we rely on an ontology, on existing standards, and basically since there were already quite a lot of ontologies and good knowledge, previous knowledge, we rely on that proven concepts. So basically we take the infrastructure description, which was already developed in ADC, and the description for the dynamic elements, which was developed in VBM. So basically combining their methods from different European projects to in the end come to a suitable concept for us. As said, we do that on different abstraction levels, and then trying to really cover all relevant elements of the ODD, which is here represented on the left side by the 6-layer models. And then, of course, on the right side, as said, important for us is the common language, but then also on the logical definition to be very efficient, to have a common understanding how to define scenarios logically, including their parameters and also relation between scenarios and scenario parameters, including their distribution. And for the three on the bottom, there we develop certain tools, which are then basically all interact with that scenario concept. Actually, I can't show you tools right now because they're actually all in development. However, as said, there won't be just 1 or 2 tools, but there will be more than 10 tools for that collect step, and also more than 10 tools for that exploit step. Actually, a bit less for that project since that's a rather special topic. But so we will have quite a number of tools, because what we're saying is that there is not that one methodology which is suitable for each and every aspect of the traffic identification, nor for traffic or scenario generation. And yeah, why is that the case? Because yeah, going into that individual steps, for that collection or identification extraction, we do use different data sources. So the most important one, that's the one I've already showed you, that scenario source data, with the different data sources from work package 3 and work data sources from 3 and 4. But there is then also other data used as weather data or another certain ground truth data, which we then use in that identification to firstly identify these concrete scenarios. Then within that exploit step, we basically use that along again with the scenario concept, potentially with additional knowledge for modeling, for bringing in assumptions, but also with certain requirements and purposes. What do we want to exploit it for, or what we want to generate a scenario for, to then generate, based on that concrete scenarios, based on that knowledge, concrete, and then either scenarios or test scenarios which we can then use, and which are then also used in that project step. Meaning that we basically utilize that, use that in also driving simulator simulations, and out there we then get again knowledge. We can get concrete scenarios, which we call scenarios of tomorrow, so future scenarios which we cannot investigate, but also behavior which we can then utilize again to feedback into our other steps. And just having the short look, how does it look like? So I said we do have our data, then the identification, extraction. To a certain extent, we do have then these tools enriching these scenarios, and then generating, and as said, then that feedback loop, scenarios of tomorrow, and utilizing that knowledge again to enrich, to generate, but also to generate new data, and then feeding that in the initial step of our process. As said, different tools for that are developed for different aspects of the ODDs. And what's quite important for us is that we are there quite diverse. So on the one side, we are considering naturalistic driving data, we are considering accident data, but we're also considering stochastic approaches. On the other hand, we're using LLMs to generate scenarios. So really having the range and considering different specifications and requirements of different stakeholders. That was the short overview from my side. Thank you very much. And of course, I'm also happy to take questions.
Thank you, Christoph. I think now we have concluded all the presentations, and I would like to ask all the presenters to open their cameras, and we can proceed on the any questions that you may address. I have seen that already one question has been answered by Marco, so I would like to ask Kirsty Aquilina if needs any further explanations, but till that, I see another question again from the same person. So the question is the following: how do you quantify the reality gap between real data and data generated through simulation or Gen AI? I don't think I think that this question is addressed to Bill, if I'm not mistaken, but in any case, you
Yeah.
can take the floor. Yeah.
To answer the first one, the SSD, I think it was also shown in other presentations, but I will just go with one sentence, that it's the scenario source data, and it is how in Synergies we call the data, which will be the input to the scenario generation tools. And they are object level data along with the HD maps. Now, regarding how to quantify the reality gap between real data and data generation through simulation. Well, here, the idea is that we record data in real environments and then reproduce the scenario and the map in a simulation. And then we, and also we perform the experiment in a digital twin. Then we use both the datasets created from that process to train an AI model. Since we have a digital twin and we don't only have a simulation data, we will use some similarity metrics in order to determine if the output data, if the synthetic data are realistic enough. And we are in the process of this. But
Okay, thank you, Bill. Anyone else that needs to comment on what Bill has just said? No? Any other questions that you want to address? I don't know, Marcos, you feel that you have explained thoroughly the other question on the Q&A about what is SSD. I don't know if you want to elaborate further.
No, I think so. Actually, also Mark provided a link where more information can be found, and I think there is an okay from Kirsty, so I think it's done.
Okay, perfect.
you are muted if you talk.
Yes, I'm talking again and I'm again muted, but sorry for that. I say that if anyone wants to raise the hand so we can facilitate the process and make the question faster, of course you can do so. I can open your mic and cameras, or you can write any questions that you may have on the chat. Or of course, any of the speakers, if you want to add something else that you think that you skipped, of course you can take the floor and ask. No. So I think if we do not have any other questions, I would like to thank the speakers for their insightful presentations, and of course all of you that attended this second webinar of the Synergies project. This webinar is part of our ongoing effort to ensure transparency, collaboration, and technical alignment across the CCAM community. Please don't forget to follow our updates, follow us on social media and our website for more updates. Feel free to reach out to our Synergies teams for any further questions or collaboration opportunities. We are going to upload this webinar at our website and our YouTube channel. So stay tuned. Have a great day ahead, and thank you all for being here.
Thank you, Dimitris. Bye-bye.
Thank you. Bye.
Bye-bye.